we're going to start we're going to start talking about a new batch of identities now. So far we've been introduced, well, these we already knew, okay? The new ones were the Pythagorean identities, and even when you learn new ones today and, and for the rest of this chapter, the weight of these Pythagorean identities, like their VIP status never diminishes, right? They are still like the identities. So today we're going to talk about what we call even and odd identities, or odd and even identities. And the reasoning behind these is this. If my angle is 30 degrees, that's right there, right? That's 30 degrees. And now if I ask you, what is the sine of 30 degrees? We know how to do that, right? What's the sine of 30 degrees? Not root 3 over 2. It's 1/2. Okay, it's this vertical side, it's 1/2. Now, suppose instead of 30 degrees, I make my angle negative 30 degrees. Now, what's sine of negative 30 degrees? Now it's negative 1/2, right? So what happened? Look in here. I had sine of 30 degrees, and then I changed the angle to the same angle but negative. And when I did that, the value of the sine became negative. So that's what this even and odd identities tells you. It tells you, if you look here, if you have sine of negative theta, it makes the entire value of the sine negative. Okay, what do you have to know from that? If you have sine of a negative angle, basically the negative comes out and you have negative sine theta. And because cosecant is 1 over sine, it's the same thing with the cosecant. The negative comes out and you get negative cosecant of theta. Now, in this diagram up here where I have my 30 degrees, in green, okay, so if the vertical is the sine, which leg of the triangle is the cosine? The horizontal is the cosine, right? So in this is the cosine of 30 degrees. Okay? And the cosine of 30 degrees is root 3 over 2. Now, if I go to the bottom triangle in the red, the vertical is the sine, and the cosine of negative 30 degrees is that one. How is that different from the cosine of the one on top? But it's the same side, right? Cosine of 30 degrees is still the same value, root 3 over 2. So how do we use that in here? What happened? What is it? Okay, in here, if I have cosine of negative theta, the negative just gets engulfed, and I end with just cosine of theta. And because secant is the same, it engulfs the negative, so secant of negative theta is just secant. No negative. Right, the negative gets engulfed. If there is a negative angle, it just gets engulfed, okay? Different situation there. That is independent of this. Make it bigger. Now, if you have tangent of a negative angle, tangent is like the sine. The negative comes outside. Okay? All right. So for the first few here, we're just going to evaluate these. So for the first one, I have cosine of negative pi over 3. Now, if you have cosine of a negative angle, what happens to the negative? It gets engulfed and it just goes away. So that is the same as cosine of pi over 3. Now, to evaluate this, I need to go back to chapter 4, like in the beginning of chapter 4, right? Pi over 3 is like my 60-degree angle, right? So if I have my 60-degree angle, this is root 3 over 2, and this is 1/2. And because cosine is the horizontal side, this is going to be 1/2. Well, this was from section chapter 4, right? I draw my triangle with the 60. Cosine is always the horizontal, okay? Whether you're in France or like even in the southern hemisphere in Australia, cosine is still going to be that horizontal side, okay? And sine is going to be the vertical side. Okay, here I have sine of negative 45. When it's a sine, the negative will come out, and this is going to equal to negative sine 45. Now, for that one, my triangle is the 45, 45, 90. And remember, for that one, I had 1 over root 2 for both of them. So this is going to equal to the negative from before. Sine is always the vertical side, so it's 1 over root 2, and there we have it. Okay? Correct. Okay, next. I have a tangent of negative 7 pi over 6. Divide and conquer. First, we deal with the negative. If it's a tangent, the negative will always come out. So this is going to be, it's going to be negative tangent 7 pi over 6. Okay? Are we cool with this? Now, this one we're really going to have to go back and back. Okay? So, 7 pi, how are we going to find tangent of 7 pi over 6? First of all, what was 7 pi over 6? It was 1 and 1 over 6 pi, right? So in what quadrant will that fall? It's 1 pi and another 1 over 6 pi. That's in quadrant 3. Now, what's the reference angle? Pi over 6. So what triangle is that? For the 30 degree though, right? So I have 1/2 root 3 over 2. Okay. So this is going to equal to, I have the negative from before. Now, my tangent is in, my angle is in the 3rd quadrant. Over there, tangent is positive. Okay. But what's the value of it going to be? 1/2 over root 3 over 2. And remember what we got from that? It's going to be negative 1 over root 3. Okay?
So how did you get to the...
So for this one, all right, it's cosecant, which is like sine. So what's going to happen to the negative? It's going to come out. Even at this point in my life, I just go and put that negative there because I don't ever want to lose track of my negatives. Now, 5 pi over 3, right? 5 pi over 3 is 5 over 3 pi, correct? Which is 1 and 2/3 pi. Let's see, 1 and 2/3 pi. Are we all okay with this? Okay, so let's see what quadrant this angle will fall in. I have 1, and now I have to go another 2/3. So do I have to pass that 1/2 pi? I do. I have to go all the way to the fourth quadrant. Okay, so now I'm in the fourth quadrant. Now, pi over 3, which triangle is that? The 60 degrees. Look, I've already drawn one there. I don't need to reinvent the wheel, okay? So I'm just going to use that one. Okay, so okay, so that's cosecant. And we just said that it's in quadrant 4, right? In quadrant 4, is cosecant positive or negative? Negative. So I need to put in that other negative there. Okay, that makes or breaks the problem here. Now I need the cosecant of the 60 degree. Cosecant is like sine, so we're going to use the vertical side, but cosecant is the reciprocal, so it will be 2 over root 3. Okay, yeah, there was a question here.
Yeah. So why is the
Why are there two negatives? The red negative came because there was a negative angle here and that came out. Okay, so that's why that red negative is there. The purple negative is because when I did my unit circle here, my angle landed in the fourth quadrant. And because I'm looking for cosecant, in the fourth quadrant, cosecant is negative. So that's where the second purple negative comes from.
So the reason why it wasn't in the other one is because tangent is
Positive in that quadrant, correct.
So you have to take it
So you have to take it into account. So now the two negatives become positive, and this is just 2 over root 3. Yeah. So we're going to move into simplifying some trig expressions. All right. So these types of questions that we're going to do might seem like they're open-ended. I try in this, to sort of like put everybody on the same page. Okay. In the real world, you do these as parts of bigger problems. So in that case, you sort of make these look like something that will match the rest of your problem. Here, when I say simplify, I've laid it out for you guys. And let me tell you what I mean by that. So, what you're going to do first for these problems, listen, what you're going to do first for these problems is this. Scan your problem. If you have a mix of functions, sine, tangent, cosecant, and so on. If you have a mix of problems, rewrite them in terms of one trig function or in terms of sine and cosine only. So if you have tangent, cosecant, sine, put everything in terms of sine and cosine first. Then, how about, what does it mean to simplify? The result should contain sine and cosine only, but such that no further operations are possible. All right, so basically convert everything into sines and cosines. You're going to have to use the identities, all right, but in different form. Okay, so a lot of these, when we start solving them, you're going to say to yourself, well, wait, how was I supposed to know how to do that? Okay, you weren't. You didn't. This is why I'm telling you. I've tried to put on this sheet like examples of each type of problem that you will get. Now your job when you go home is to mimic what we've done here to match what you have to do for homework. All right, so let's start with one of them. I have here 1 over cosine, and then in parentheses 1 minus sine squared. All right, the 1 over cosine of x is as simple as life will get. There is really no simplifying that any further. So I'm going to write that here or down. Now, when you see something like this, Okay, so let's just examine what I have here. I have a 1 in conjunction with a sine or a cosine, a trig function squared, right? 1 with a trig function squared. When you have that combination, you have to immediately think of Pythagorean identity. All right, so you go in your mind and you think of, okay, which Pythagorean identity involves sine squared? Well, it's that first one. So let's write that here. Sine squared x plus cosine squared x equals 1, right? Now, in my parentheses in the problem, it has 1 minus sine squared x. So guess what I'm going to do? These identities, they're not rigid. They can change form. You can do any math operation as long as it's like a legal math operation. So here I'm going to subtract sine squared x from both sides. Remember, you have to do it from both sides. When I do that, let's see what I have left. I have cosine squared x is equal to 1 minus sine squared x. Okay, now here is the game changer. I have here 1 minus sine squared x equal to what? Cosine squared x. So when I go to my problem, 1 minus sine squared x is equal to what? Cosine squared x, right? Okay, so here I just figured out that 1 minus sine squared x is equal to cosine squared x. Okay, so here's what I'm going to do. I'm going to put this into here. So now I replace 1 minus sine squared x with cosine squared x. Okay, so let's take a look at that for a minute. From the identity on this right-hand side, I saw that 1 minus sine squared x is the same as cosine squared. So if I have 1 minus sine squared here, that's the same as cosine squared. So I can just swap one for the other. I take out the 1 minus sine squared, and in its place, I put in cosine squared, because this tells me that they're equal. Okay? Now, let's see what I have left. If you want to combine these fractions, you can. I have cosine squared x on top, cosine x on the bottom. Does anything cancel?
You could cancel the square and the cosine.
Right. One cosine from the top cancels with one cosine from the bottom, leaving me with just cosine x. Okay? And that's what we do in these problems. This is what it means to simplify. I had a more complicated function now simplified into a single cosine, right? So look at what it says here for step number 2. Result should contain sine and cosine only, or sine or cosine only, with no further operations possible. There it is. Okay, yeah.
How did you get this stuff you multiplied to divide?
This is cosine squared x over 1. And so I just multiplied the numerators and the denominators. Okay? All right, let's take a look at this one. Look at what I have here. I have cosine, tangent, sine, and cosine. When you have a mix of trig functions like that, first put everything in terms of sine and cosine. So write everything in terms of sine and cosine. Okay, so this is going to equal cosine of x just stays as is, but tangent of x becomes sine of x over cosine of x. Okay? Minus, the only thing I'm changing is the tangent. Yeah, I'm just replacing tangent with sine over cosine because they're equal.
So what if you have it's
It could be, and then you could do 1 over cosine. Yeah.
How do you look at that problem with
So that's the thing. The first thing I do when I scan the problem is everything just sine and cosine? If not, I put everything in terms of sine and cosine.
how do you do it
That's
in terms of because you're just dividing by cosine?
no, I'm not dividing. Remember,
Oh,
our
because
tangent is sine over cosine. Yeah. Okay. So now, can I okay, so look at this one. Can I cancel anything out from this part? The cosines will cancel out. So let's see what I have left with. Sine of x minus sine of x cosine squared x. Okay. Here is a situation now where you will look at this.
Can't sine of x and sine of x?
No.
Because the cosine
Right. This is just sine of x. The other one is sine times cosine. They're not like terms. And so I'm going to do something here. And when you see me doing it, chances are you're going to say, okay, how was I supposed to know to do that? Well, until now, you didn't know how to do it. That's why you're in this class and you're learning how to do it. Okay, so here's now how I look at this problem. I have sine of x plus or minus the same thing multiplied by something different, right?
I do not understand that.
No, you do. I have sine of x minus the same thing, but it's multiplied by something else.
So you're going to move. Why do you say plus or minus?
Because this is either going to be a plus or a minus in your problem. Now it's a minus, but it could very well have been a plus. Okay. So what I do here is factor. What can I factor out? A sine x. Okay? So here I'm going to factor out sine x. Okay, when I factor out a sine x, let's see what I have left. When I factor out a sine x from the left side, what do I have left? What am I left with?
1 minus.
A 1. Okay, if you have,
Which sine of x did you take down? Oh, like the first one.
if I have x squared minus, let's say x, if I have x minus xy, all right, can I factor out an x? Okay, and then what do I have left? 1. How do you know that that was a 1? What did you do in your head? How do you know? Because 1, okay, so here I'm factoring out a sine x. So when I factor out a sine x from here, what do I have left? 1. Minus, from here, if I take out the sine, what do I have left? Cosine squared x. Now, look at what I have. I have what I had up here with the 1 minus sine squared x. I have a 1 in conjunction with a trig function squared. When I have a 1 in conjunction with a trig function squared, I have to use a Pythagorean identity. Yep. So let's see which one we're going to use. I'm going to do it in green this time. So sine squared x plus cosine squared x is equal to 1. Now at this point, I want to make it look like 1 minus cosine squared x. So let's see what we can do. Let's just subtract cosine squared x, see what we get. Sine squared x is equal to 1 minus cosine squared x. Now, compare this with this. 1 minus cosine squared x. In the green, what does it say that equals to? Sine squared x. So now I have sine x times sine squared x. Yeah, of course you can.
Multiplying it from the beginning of.
Together, sine x times another 2 sine cubed x. That's it. This isn't that bad. In this one, I have tangent and cosecant. So my first instinct might be, hey, let me change everything to sines and cosines. But then I realize there is another thing happening. I also have a 1 in conjunction with a trig function squared. That takes precedence here. When you see a 1 in conjunction with a trig function squared, that should alert you to a trig identity, or actually a Pythagorean identity. It does. And look, we actually have a Pythagorean identity with tangent squared plus 1. It actually is secant squared theta. So I can replace the whole numerator with secant squared x. The bottom stays cosecant squared x. Wait, what? This is an identity. 1 plus tangent squared x, it's an identity. It equals secant squared x. It's one of the Pythagorean identities in the box. Now that I know, okay, so now I have secant squared over cosecant squared. Now I look at this and I kind of don't have much to do, so I say, hey, let me change everything into sines and cosines. Okay, in the numerator I have secant. Secant is 1 over cosine, right? Yes. Secant squared is 1 over cosine squared x. Hang on. In the bottom, I have cosecant squared, and that's 1 over sine squared x. Hang on. Now, it's not cotangent. Let's not jump ahead. Okay, this is where now you have a complex function, a complex fraction. All right, so I have a denominator on top, cosine squared. I have a denominator on the bottom, sine squared x. Can I cancel those? I can't cancel those. So here's what I'm going to do. I'm going to use, like, you know, what I learned back in the day in middle school with multiplying and dividing fractions. If you have something divided by a fraction, what do? Multiply by the reciprocal. So what I'm going to do here is 1 over cosine squared x times the reciprocal of the denominator, sine squared x, over 1. Now, when I multiply across, what do I have on top? Sine squared x, and on the bottom, cosine squared x. That is tangent squared x. Okay, now look. In my directions to you, I said, put them in terms of sines and cosines so that no further operations are possible. So technically, this fits that description. So if you want to leave it as sine squared over cosine squared x, that is acceptable. If you want to go one step further and say tangent squared x, that is also acceptable. Okay? I will take either of those two. It's fine. Okay, now, for homework, I had assigned these ones.